So here's a basic example. You might be asked, just given something like this, to find the amplitude, the period, and the phase shift. Okay? So just plug into the formulas or use the knowledge that you were given. If you remember, the amplitude was obtained by the coefficient. So that's why we know the maximum is 4 and the minimum is -4. The period is 2 pi divided by the frequency, in this case 2, the absolute value of the frequency. So the period is pi. That means that the sine graph that normally took from 0 to 2 pi to complete itself for one cycle is now going to take from 0 to pi. All right? So we're going to be able to fit 2 of them in there. So if we set that phase shift 2x plus pi equal to 0 and solve for x, what that tells us is what was once 0 is now -pi/2. All right? So what we do is we know that should be our starting point. The whole graph has been moved to the left pi/2 units. Okay? So to figure out where the fundamental cycle begins and ends, we're going to take this expression, the phase shift, and set it between the two endpoints of the normal fundamental cycle. Here, when we solve pi x by subtracting this pi on both sides, then dividing this 2, we get this answer here. So what that tells you is that this and this are going to be your endpoints for your fundamental cycle. One quick note, a way to check to see if you're doing things correctly. The difference here, if I take pi/2 minus a -pi/2, I should get what the period was. If you remember, the period up here was pi. So indeed, if you were to look at the difference between those two, you would get two negatives become a positive, and when you add, you get 2 pi over 2, which is equal to indeed pi. So we know we're in the right direction because the difference of our fundamental cycle is this. Hopefully you're understanding these. The only way to really truly get it is to do a few of these. And you can't really graph cosecant and secant unless you understand cosine and sine. So what these endpoints are telling you is that it's no longer 0 to 2 pi where it starts. Now our graph starts and ends, our fundamental cycle starts and ends -pi/2 to pi/2. So rough sketch would be something like that, okay? But we still have to figure out what these points are here. So what are these points? What are they going to be? How do we figure them out? That's the next phase to this question. So the way we do that is we take our period, which was pi, and divide it by 4. If you remember in the trig basics video, I told you to pay attention to the fact that the sine graph is actually divided into 4 sections. If we look at a basic graph of sine, so the basic graph of sine again, if we were to look at it, it would look something like this, and we would have 4 important points. The first and the last are where the period end and begin of the fundamental cycle. And then there's these other players that play a key role in our understanding of the sine function. So where is the peak going to be on our transformed function over here is the question. Where is it going to hit the axis? Where is it going to be on the bottom and back to the axis? So again, we are going into infinity and negative infinity, repeating this graph. So the way we look at it is we say, okay, well, I know that if I were to break this up, I get 4 regions. There's 1 there, 2, 3, 4. So what I can do is take the period, which is the distance between here and here, or in this case, between these 2 numbers, and I can take that period and divide it by 4 or multiply it by 1/4, whatever makes you happy. All right? So looking at that on this problem, if you remember, our period was pi. So you take pi and divide it by 4, and that's what you add to negative pi halves, the beginning of this period here of the fundamental cycle. So add pi fourths to negative pi halves 4 times, and if you do it correctly, you should stop at pi halves. All right? So looking at that, this is what that would look like. You can see here's the negative pi halves, and if you were to go do a little bit of calculations on the side, let me just show you what that would look like. So if you remember, the period was pi. If you multiply it by 1/4, you get pi over 4. So I'm adding to negative pi halves this pi over 4 times, giving me a negative 2 pi over 4. So when I do that, I'd get a negative pi over 4 when I add them. So that's my first little space. And if you were to add pi over 4 to negative pi over 4, that's actually pretty easy because that gives you 0. That one's going to give you pi over 4. And if you do it one more time, you'll see that you would get 2 pi over 4, which gives you pi over 2, which is where we were supposed to stop. These were the endpoints of our period. If you remember from the PDF, the handout, this is on the website, by the way. So you can see here, these are the points. And then here's a fundamental cycle, okay? So if we start here and we go a distance of 2 pi added to negative pi over 2, our frequency here, this 2, tells us that we should have 2 complete sine graphs there, okay? So it keeps going in either direction and repeats every pi as a result. Next video, we're going to go over the phase transformation rules for these guys here. And again, you cannot graph the secant and cosecant unless you know sine and cosine well. So I hope I've improved your understanding of graphing sine and cosine functions. Make sure you practice a few of these. At first, it may seem overwhelming and intimidating, but if you do 3 or 4 or 5, I guarantee you'll see that it's just a few steps that you gotta get down. All right? So practice, practice, practice as always. Thank you and have a nice day.